Okay, let's download some Musebots and actually see them in action. So to do that, you have to open up a browser and point it to musicalmetacreation.org. There you'll find the Musebot tab, and it gives you some information on the bots themselves, what we're trying to do. The news explains some recent events within the Musebot world. Videos provide some examples of Musebots in action as well. But we're going to go to the Musebot Getting Started page. Now this page gives you some information on how to actually start creating your own Musebot, but we're just going to download some Musebots to get you started here. So the Getting Started collection is just a few Musebots that have been put together along with a conductor just to demonstrate how they're working. So you can download that here. It does take over 300 megabytes, a bit of time to download, and I've done that already here on my desktop. If you're running Windows, then you have your own separate collection here to download. Now, if you are running Mac OS 10.12, which is Sierra, and that is in fact the operating system that this computer is on, there are some additional steps that you have to take. And that's because Apple with Sierra has implemented some gatekeeping features, ostensibly to safeguard itself from applications that are downloaded from the internet. And because Musebots are applications that are downloaded from the internet, they get corralled into a special location, and that kind of destroys the way the Musebots communicate with one another. So you have to follow these special steps to allow them to communicate to each other. So as long as you read that guide and follow those steps, everything should be okay. So once you've downloaded the archive and unzipped it, this is what you'll see. So there are 3 separate folders within that master folder. The ensembles are a list of text files, or several text files. In this case, it's just one text file. And that just is a way to launch Musebots all at once, to create your own ensemble and put those together. We'll look at that in a second. Then we have the Musebot Conductor application. Inside of that is the Mac's Musebot Conductor app. And you can have any number of applications that are conductors that you want inside this folder, but it's important not to change the name of the folder itself. So the Musebot Conductor application has to retain that name. And the reason for that is the conductors look backward when they're launched in their directory structure to find this actual name. When it finds the Musebot Conductor application, it then looks for the Musebot folder, and within that folder are all the Musebots that it has access to. So I'll just launch that right now, and as I said, it will look for that folder, the Musebot folder, and it has found it here. So if you were running Sierra and didn't follow those instructions, this would in fact be empty, and that's not a good thing. But it has found that folder, and it's populated this menu with all the Musebots that it has access to. Now this particular conductor, when it launches, it starts playing right away. You can see the yellow button is on. And what the Musebot conductor is doing is simply providing a beat right now. It has Musebots don't have a conception of bars. Individual Musebots might do so, but the conductor itself is just counting up. It's just counting up beats. So we see we're at beat 79, 80, 81 right now. And the tempo it does have control over, so I can slow the beat down. But all that's happening here, it's the Musebot conductor is simply counting up in beats. It's just conducting forward. So to launch a Musebot then, I'll just launch this very first Musebot, the AE House Beat Bot. And so just to fade that down so you can actually hear me. So by doing that, you can see that the Musebot was launched, and it started playing right away because it does have the beat. It's getting the beat from the conductor. It also has an overall volume that I can control from the conductor as well. So here's an example of a message that's being sent from the conductor to the House Beat Bot. So not only are the beats being sent as messages, but I can also control the level of the Musebot itself. The tempo itself can be obviously controlled here, right? So I can hear it's now playing a little bit slower. I'll go back to 120 beats per minute. Okay, so now some things about the individual Musebots. So this Musebot, the House Beat Bot, it happens to use a corpus. So it's generating its beats based upon an analysis of about 50 pieces of music that were given to it, and it's generating beats based upon that knowledge. So we don't control what the MuseBot is playing. The MuseBot itself is generating these beats, and also how it's reacting over time. So you can hear it's not playing the same thing. It's not simply generating a beat and playing it over and over again. So there's some internal logic that each MuseBot will have to change the way it's playing. I'm going to launch another bot just to give you an example of what happens. So I'm going to launch a bass bot. So the bass bot needs to know some information. So we do have the tempo that's coming from the conductor, but what about some other information? We said there's no notion of bars within the MuseBot conductor. Well, the housebeat bot does have a notion of bar. It's playing in a 4/4 16th note pattern, and so it's actually sent that information as a message to all the other MuseBots, and this walking bass bot has picked up on that. So we can see here that the meter, it knows that it is 16 16th notes, so it got that information from the house beat bot. The Tala is, some of the beat bots work on this notion of subdivision, and here the subdivision is 4 16th notes in a row, 4 4 4 and 4. So that's your standard 4 to the floor, and the bass bot has picked up on that. So it knows the meter that the house beat bot is playing. But the walking bass bot needs to know some other information. It needs to know what notes to play. It doesn't have any conception of chordal harmony at the moment right now. So there's another MuseBot in our collection that'll do that for us. So the Miles Chord Bot. So this bot is another corpus-based bot that it uses a corpus of Miles Davis tunes from the 1960s, and it generates a harmonic progression based upon that knowledge. So it doesn't generate any sound whatsoever. It's simply sending out messages. It's simply sending out the chords that it thinks that it feels should be played by the ensemble. And in this case here, it noticed that it has picked up a phrase length. So the phrase length are 8 bars. That's again come from the house beat bot. That has been sent by the house beat bot. The meter is 16 16 or 4 4. Now it's generated progression, not just a list, but when it should change as well. So it has determined that how often it should change. And it's generated 4 separate chords and it's playing through it. And so once this information has been sent, we can hear that the walking bass bot is now reacting to that. It knows what to play, and it's playing these notes based upon a certain pattern. And the pattern, like when it plays, is dependent upon the meter and the Tala that it's received from the house beat bot. I'm going to add one more bot now. I'm going to add the Rhodes bot. And this is a Rhodes piano bot. It has some of the internal sounds within it. I'm going to fade that down a little bit as well. So the Rhodes bot is also sharing the harmonic information that the Miles Chord bot has sent out. So that's how the walking bass bot and the Rhodes bot are playing together, because they receive the same information that's being transmitted by the chord bot right here. So we do have a kind of interesting style mixing that's going on. We have this sort of 1960s walking bass, Rhodes piano, and chord progression that's happening, along with a house beat that's being generated from tunes from the 1990s. So, you know, what would happen if we changed the way the meter is being created right now? Because right now the walking bass and the Rhodes bot are locked to that 4/4 pattern. So I'm just going to press this kill button here on the conductor, and what that's going to do is going to fade the house beat out. It's going to send the message kill to the house beat bot. The house beat bot will take 5 seconds. It'll slowly remove itself from the ensemble, and then it'll stop as an application. It'll quit itself. And now instead I'm going to launch the Jazz Beat Bot, which is a different way of generating beats. Fade that down a bit so we can hear ourselves. Okay, so now that the Jazz Beat Bot has launched, some things have changed. So it has a different conception of meter. It's not locked to 4/4, and it's actually, in this case, the Jazz Beat Bot launched, and it has a meter of 2016 or 5/4, so it's playing a 5/4 beat. The phrase length is 8, so it's still playing an 8-bar pattern, and the subdivision of that 5/4 is no longer 4/4/4/4 with an additional 4. In fact, it's this grouping of 2/3 2/3 3/3 2/2. That's been communicated to the other bots, and these other bots happen to understand that. So the Jazz Beat bot doesn't know whether or not the walking bass bot understands it, but it's just giving it some information. This is how the Jazz Beat bot is conceiving of meter. These other bots happen to understand that, and they are reacting, and they're placing their own onsets based upon the Jazz Beat bot. So there's some other additional information that's being passed on by the Jazz Beat bot. So we can see that there's a lot of change. That's the way the Jazz Beat bot is playing itself. It has a great deal of change in its density. And density is essentially, or what I'm calling here harmonic density. Density is how many notes per second or per bar or per beat that any individual bot is playing. And so that is changing quite a bit because the Jazz Beat bot is generating every phrase, every 8 bars at the beginning of that. It generates this curve that it follows. And you can see as it's going down, it has a low density. It'll pick up over the course of those 8 bars and starts to play a little bit more actively. That information, so the curve itself is not being messaged, but what's being messaged is this density, is how it is interpreting that message. So the walking bass bot and the Rhodes bot receive that information. So here we're seeing we're a little bit higher density, 0.8, 0.78. And these other bots are reacting to them. They're also playing a bit more densely. In reaction to what the beatbot is sending out. So the beatbot itself, the patterns that it's playing are sort of internal logic that it's following, but it's sending out some higher level information to the other bots. In this case, how the meter is being organized and how dense it's being interpreting that meter. The other bots are reacting to that. And again, it's important to point out that even though the Jazz Beat bot is sending this information out, there's no guarantee that the other bots that are listening understand that information. These, in fact, do understand that information. So these bots will continue to play for quite a long time. The Jazz Beat bot, there's one additional feature to it, is that it'll stop playing at a certain amount of time. So it's only generated 15 separate phrases, and it gives us this information right here. If I launch it again, it may generate a different number of phrases. But once those phrases are up, so right now it's on phrase 15, or sorry, phrase 9 out of 15. Once it gets to the end of that, it will actually stop playing. It'll quit. It'll exit. Once it's exiting, it'll actually, or while it's exiting, it'll send a message out to the other Musebots saying that it's exiting. These particular bots understand that message, and they too will exit. So after 15 phrases, all 4 of these bots will quit. Now we're just going to look at the way the ensembles work. So the ensembles, what that is simply a file, text file that gives some information on what bots to use at any given point in time. It gives some information on tempo. So in this case here, the tempo, the first line is 76 beats per minute, a duration of 300 seconds. So that would be 5 minutes. Then here's a list of the bots that are to be launched with some additional information. So there's a gain control, it's how loud the bot should play, a delay, and this particular bot, it will not play for the first 30 seconds. So it'll launch these bots, and after 30 seconds, it'll launch the Jazz Beat bot. The Miles Chord bot does not have a gain because it does not generate any amplitude, doesn't generate any sound. And the Rhodes and the Walking Bass bot both have a gain of 0.9, which is 90% of their value. So to initiate an ensemble, here I've selected this first ensemble, and I'll click the single button, and it'll play through the ensemble. So the first thing that'll happen is that it'll launch the Miles bot, because remember the Jazz Beat bot has a delay of 30. Then it'll launch subsequent bots. Just move that a little bit over. Once all the bots are launched that need to be launched, the conductor starts and it starts to play. So now they're communicating their messages. Note that the Jazz Beat bot is the meter generating bot. So they do start off with a default meter of 4/4, and they're starting to play. And now after 30 seconds, just fade those out. So after 30 seconds, the Jazz Beat bot initiated. It generated the meter, sent that information out, and the other Musebots adapted to that meter. Now, the last thing about the ensemble is that there was a duration to the entire ensemble, and it was listed as 300 seconds or 5 minutes. And we can see it's starting to count up now here. We're at the 1 minute point. There's some other features within the ensemble. You can kill a certain bot after a certain amount of time. We already saw the delay command. So that within an ensemble itself, things can change within it. After 5 minutes, the ensemble itself, all the bots will quit, and the next ensemble in the set will be initiated. But because we only have the one ensemble, it'll just keep quitting this ensemble and reinitializing and starting it up again. So if you want to have different configurations, for example, put in the house beat bot, you can create a new text file and just put that information in the text file and it will launch. So I'd like to talk a little bit about what's inside an actual Muse Bot folder. As I already mentioned, the conductor application looks for the Muse Bots folder, and inside of that finds the Muse Bots that it can launch and communicate with. And so within each folder, there has to be a Muse Bot itself. And in this case, it is a Mac application, as we can see by the .app extension at the end. But what the conductor is actually looking for is two specific files. It's looking for a config file and a run.command. So in each of our folders here in the Getting Started collection, we see that there are the Muse Bots themselves as applications. We see the config file, and we also see a run.command. Now what the run.command file is when the conductor launches a Musebot, what it's actually doing is initiating a terminal command, and inside that run.command is a method for the terminal to launch the application. So in this case, it is launching an application, but it can also be a command to execute a Java jar file, open a PD file, or run a super collider script. The other thing that happens is that when the conductor first starts up, it looks into the Musebot folder and it finds the config.txt file. And what the config.txt file is a listing about how the conductor can communicate with it and how the individual Musebot can communicate back to the conductor. So it contains the port information that both the conductor and the Musebot require to communicate back and forth. So when the conductor launches, it actually rewrites each of these config files to have unique port numbers. So when the actual application, when the actual Musebot launches, it reads that file and it knows how to communicate with it. The other file that's in the Musebot folder is an info.txt file. And this is meant as a human readable file that people can understand what the Musebot is actually going to do. In this case, we're looking at the house beatbot file, the info.txt file, and we can see its instrumentation. It's going to play drums, and what it's going to do, it's going to generate a beat. That we can see that the information right there. And then it gives a bit of a description about the behavior itself. So in this case, it generates a 4 on the floor house drum pattern from a 50-track corpus. So that's information that we can use in determining how to use that bot in an ensemble. But it also tells us some of the specific messages that it both sends and receives. So the only messages that it sends is the tala and the phrase information. Notice that even though it's generating a beat, it doesn't actually send what the beat is that it's generating. There's also some information that the Musebot will receive, and this particular bot only receives section information and exiting information. If we look at a different bot here, let me just look at the walking bass bot. And we could see that the bass bot is actually sending nothing, but it's receiving all of this information. So the tala, remember that from the previous beat bot, the beat bot was generating that and sending that information, and this bot will respond to that. It's also receiving note pool information and H density information. So the note pool is going to be generated by another bot to determine what chords to play, what notes to play. And the H density is a way of Musebots to communicate how dense that particular Musebot is playing. So the note pool is actually going to be generated here by the Miles chord bot. We can see that here. It's actually sending note pool information. So we can see that in order for the bots to function properly, we need to know a little bit about what messages they require, what message they are sending, because they are always communicating to one another, and if they don't understand each other's messages or are not receiving the message that they expect, then they will not work correctly together. And these bots here that are put together into this collection have been curated in the sense that they all respond to that, they all understand a lot of the messages that each other are sending. Okay, now we're going to download a Muse Bot from the Muse Bot website and get it working within the collective that we've already started working with. So we have to open up our browser again and point it to musicalmetacreation.org, and we can see here we're on the Muse Bot landing page. You can see on the very bottom there is a complete Muse Bot listing. And let's say for now that we want to add a bass generator. And so I will just select bass generators. And it gives us a listing here of these are all the bass generators that we currently have within the larger test suite. And we can see the collection is shown by the author, a bit of a description of what it does, the message that it sends and receives. And this is all the information that's actually taken from the info.txt file that we previously spoke about. So let's say here that you want to try out the Snap Bass Bot. At the bottom here you can see that there's some you can download the application and look at the source as well. So most of the bots are available in their source file. So if I just click on that, you can see it goes to Bitbucket. And here we have an individual resource, an individual repository for each Muse Bot. So here's the actual max files that you can see, all the information for that particular bot, and I can download it directly. So we'll talk about making your own Muse Bots a little later. Now we're just going to download the app. And some of the bots you can see here are available as Windows as well as Mac versions. So here is the Mac version and the Windows 32-bit and Windows 64-bit. So when I download the application, it goes to a separate server where we have all of our bots stored. So if I just click that, it will download it, and it'll appear as a zip archive. Now I'll just point to another way of downloading the apps is if you click on the complete MuseBot listing itself, and it takes you to that page directly. And what you see here now are the links to the actual server directly. So we go back to for example, the bass generators, and there they all are at once. So there's no descriptions involved, but this is the server where the bots are located. So I can directly click on that and download them. And so what I did is I went to the harmony generators, and I selected one of these. So you can see that these are all corpus-based harmony generators, the corpus of Pat Metheny, Miles Davis, which we already have within the collection, a modal chord bot, which is algorithmic rather than corpus-based, one based on the corpus of Mozart, and the swing chord bot. And this is the one I actually downloaded, the application, and it ended up here as a archive on my desk. So I double-clicked it, and here it is. There are the files that I'm going to be using. So to get it to work within my current collection, you can see I have them both open here. And I have it's important now the conductor is not running, so I don't have the conductor turned on. And there's my MuseBots. And really now all I have to do is drag this folder into the MuseBot folder. So remember, it does have the application itself, the configure.txt file, the info file, and the run.command, as well as, in this case, the source. The max source code is included here in the application. Many of the bots do not have this source included within them, and some specific data that the bot requires. Now when I go back to the conductor application, again, as I said, it's very important that the conductor is not running when I do this, because when the conductor launches, it rewrites all the config files. Because we just added the swing chord bot, it has to rewrite that as well. So whenever you add a new MuseBot, you have to restart the conductor. And so here you can see the swing chord bot and I click that. And because it the Sierra OS that I'm running, it does require me to allow it to open. And that just will happen the very first time. And then it will run. Just taking a bit to run, and there it is. Okay, so now I can have my Musebots playing. If I go back and start up the Rhodes chord bot and the walking bass bot, those will run now with, instead of the Miles Davis progression, it'll actually run with a chord progression from a corpus of 1940s swing tunes. Okay, now we're going to show you how to make an actual Musebot, or at least adapt one of the templates and explain what's going on there. So we're back now at the Musebot landing page here on the getting started, and just below where we got the collection before, now we have some source code for Mac's Musebot. Now there are a number of templates that you can use to generate or to begin working with your own Musebots and making them, but we're going to use one that's in Mac's MSP. So that downloads here. It's called the blank bot, and I've downloaded that already. And here I've unarchived it already as well. And so we can see here that there is the Max patcher. We notice that there is no actual Musebot application. That's because it hasn't been created yet. The other two important aspects, there's the config.txt file and an info file, and also a run.command. And the run command is pointing to an application that hasn't been created yet. So to get this to work inside the collection that we had previously, so there's the collection, all I have to do, if you remember before, is just drag my blank bot into the Musebot folder. And again, remember that my conductor is not running, because when the conductor starts up, it needs to rewrite this config.txt file. And that's even the case when I'm going to be working in Mac's MSP as well. So I'm going to start my conductor now. It goes through the process when it starts of rewriting all the config files. And I already have Mac's running. I'm using Mac's 7, and I'm just going to start that up here as well. So we can see that the Musebot is sending the beat information, and we're receiving that in the Musebot itself. And it's also, the conductor is aware of the Musebot because it's appeared here, and we can see that it has control over its amplitude. So that's all. That communication is happening. Now, one thing it's important to note that within Mac's, you can really only have one Musebot open at a time, and by that mean one Musebot patch. You can certainly have all these other Musebots running as applications. It's just the way that in the templates, the way the internal configuration and communication is set up. It only really allows for one at a time. We'll see why in a second. Okay, so what's going on here inside the Musebot? Let's just take a look at it. And so we can see this looks like a typical Mac's patch, right? So we see some of the different elements of it, and we'll just go over all of those elements. So this is all using vanilla objects from Mac's, with one exception, is the OSC route object. We've included that in all the templates as well here. And what the OSC route object does is it's routing the OSC messages that are coming from the conductor. And again, OSC is open sound control, and that's how the Musebots are communicating with one another. And so what the OSC route object is doing is simply taking the messages, breaking them apart, and passing them around within the patch. So the way the communication is occurring is that all the, I like to say, heavy lifting is done inside this subpatcher right here. And so whenever you make your own Musebot, you just need to include this Musebot config Max patch, and it operates as a B patcher right here. And just to show you what's going on inside of it, you don't really have to look inside it, but we will do that right now. And so we're looking at it now, and what you can see here is the text object right here is containing the config.txt file that it finds within its own folder right here. And this is the file again that the conductor is rewriting. And so this is the port number here that the conductor assigned to it. And so when the Musebot actually launches and the subpatcher is initiated, then it finds that config file, and then it loads the port and it configures itself to send and receive on the correct ports. And so it's getting all the information that it requires. So when I change my level here, that it's it understands that message coming in, and it changes that based upon the information that it receives. Okay, so this information is then sent out to the OSC in. So here's the send message, and this is why we can only have one Musebot open at a time right now, because as soon as you have another one, they're going to start talking to each other at the same time. So that's why you can only have one Musebot open at the same time, at one time. And so the Musebot config subpatcher, we can see down here, is sending the messages that it's receiving, and it's just avoiding having a patch cord coming back up to the top right here. So all the messages that are coming in through OSC are coming back up here. So the MC message, that's the master conductor message, it's sending the timing information. So if I change my timing code, you can see here now the tempo has changed as well. And I bring it back up. Okay, so what is actually coming in is not just the beat, but it's this running number that's getting higher and higher. We can see we're in the 7,000s already. And it's running at a speed of 16 ticks per beat. And so that's, in order to get a beat from that, we just have to modulo that. So we take the number, here is the tempo that's coming in. We're breaking it apart. It comes in as a single message as the tempo and this running ticks that are going higher. And we're just going to take that number and modulo it by 16. And so that, whenever it hits a 0, it's actually going to send this beat here. It's going to send a bang. And so we can see here that is the beat. Go back into presentation mode, and we can see that this beat here is clicking at the same time as the beat in the conductor. Okay, so every beat then we have a bang. The bang is also triggering this drunk object, which is moving between 0 and 10 or 0 and 9, and we have this varying number that's moving around, and that's actually going to be the probability of actually playing a note. So it's every beat, then a random number from 0 to 9 is being generated, and it's testing to see if that random number is greater than the probability of actually playing right here. And if it is, or sorry, if it isn't, then it bangs through whatever is being held in this reg object, the ZL reg object. And that's holding, what that is holding is the pitches that it can play. So this little part right here, we can see in the panel, is generating when the pitches, when something is going to occur. So it's generating the onsets. So if you want to do something more complex, this is how you would do it. Now the onset, now if it does trigger an onset, it's going to select from a list right here that is the incoming note pool. We see here the incoming note pool, but there is no note pool that has come in yet. There's no other object, there's no other Musebot that's generating anything. So if I just select the Miles Chord Bot, that is going to start generating a note pool. And we can see here, there's nothing come in yet. And as soon as the, oops, there we see the Miles Chord Bot is now active. You can see it right there. And it's sending some information. So here we see these are the MIDI pitches that are coming in. It actually hasn't triggered anything quite yet. Actually, it has. We're just not hearing it. There we go. Okay. So it's the note pool has come in, and the way it's come in is important to discuss right here, because the Miles Chord Bot is sending a message. It's not actually communicating directly to the blank bot or any of the other bots. It's communicating back to the conductor, and it's sending a broadcast message. And that's what's coming in up here. So we're breaking that apart in the OSC route object. And it's coming out of here, and we see that there's two pieces of information that's alternating between either an H density from the blank bot. It's actually sending it over here. as well as the Miles chord bot is going to be sending the note pool information. So here's some other possible information that it's looking at, that this particular bot is looking for. Now the Miles chord bot does not send out the H density and the Tala information, but if we opened up one of the beat bots, for example, that information would be coming in. This bot doesn't do anything with that information, it just shows up here. We can just look at it. But it does want the note pool information, so that's coming out here. We slice off the first piece of information. The note pool is going to be eaten by the OSC route object, that first message, and then the next message is going to be the object that, or the bot that sent them the message. And in this case, it'd be the Miles chord bot. We're going to slice that off. And so what's coming in then at this point here is the actual note pool. So it's these pitches that it can play from. So that is being stored in this reg object right here. And then when the little algorithm here to determine when to play a pitch, it's banging that through. So this part here is simply selecting from those pitches, or is looking at the length of the list, choosing a random number based on that list and pushing it through. It then changes the MIDI note into a frequency, and that goes into this really simple oscillator right here, or really simple synth that is really just a triangle wave with a little bit of an envelope on it. So the audio is then coming back into the Musebot config subpatcher here, which is also handling audio output right here, right? So that's how we can fade it in and out here based from the conductor. And it's sending that information out. So with this object, it's just showing you three really simple aspects. It's showing you how to deal with when something should happen here, because we have the timing information coming in from the conductor. This is determining when things happen. This happens to be a pitch-based synth, so this little patcher, this little part right here of the Musebot is determining how the pitches are being generated, and this generates the sound. And again, Musebots have to create their own sound. We do have some Musebots that are Max for Live, Musebots that generate sounds through Ableton Live, but the more common ones have to generate their own sounds, their own synthesis methods here as well. The last thing I'm going to just point to here is that this Musebot is sending out some information as well. So not only is it receiving information from other Musebots, but it's also sending it out. And what it's going to send out here is simply this probability of playing right here, and it's going to be called the H density. That's just what the message that I decided to call it. And so just to show you what's inside of that subpatcher, this is how you typically formulate how to make a message. You build the message at this point here. So what it needs then is this particular OSC message to be built. So the first thing in the message is the broadcast. So that's telling the Muse Bot conductor that this is a broadcast message and it should be broadcast to all the Musebots. Then right after the backslash here is the actual message that's going to be sent, and this is the H density message. Then in a separate message item here is the actual Musebot that's sending the message. So in this case it's blank bot, and we get that right here from the agent ID. So that is derived from not the name of the subpatcher, but the name that's found in the config.txt file. Right, so that's all handled in here, and we find what the name is, the blank bot. And then the information that's coming in here, if we follow it from this slider right here, that it's coming in, and this is the value that's going to be sent out. So if we like this particular bot, the way it's generating, then so to make it actually work within the ensemble, then here I have it in, this is my presentation mode. So I'm just going to now build the collective, and I'm going to build it. I don't have to include anything because it's automatically including all those extra files. I'm just going to, for now, just save it to the desktop. And I'm going to save it as an application. There it is there. And it's going to write. And it's going to take a while to make that. Okay, so once it's finished generating the file, I can close that and close the max patch. And here is the application that was made. I'm going to just drag it into the folder, and there it is. And so because the application is reading the same config file, and the Musebot conductor already wrote the config file, and the run command is already pointing to that object, when I select it here, it should automatically run. We're opening it for the first time. Say, okay, yes. And there's the blank bot as an application. And it's playing.